Okay, so we have 2025 in AIME 2. So problem number 1. The 6 points A, B, C, D, E, F are aligned in a straight line in that order. Suppose G is a point that is not on the line, and then we are given some segments. Find the area of the BGE. So let's draw some uh, points to make a straight line to see how that they are related. So I'm going to make, let's say, a line like this. So let's call this is A, B, C, D, E, and F. So we don't really know how far from each, but I just made it somehow equally. And what we have is AC, which is, these two. BD is like these two, and then C is these two. So maybe I should label those. Like I'm going to call this like N1, N2, and actually, let's use just letter A, B, C, D. So with that in mind, AC is 26, which is A plus B is 26. BD is 22, so B and D is B plus C is 22, and then CE, C to E is C plus D is 31. And then DF is 33, so DF is D plus E. And then AF is 8 through F. It's just some of these all. So A plus B plus C plus D plus E is 73. And then CG and DG is given, but the point G is outside somewhere. So maybe I'll just choose that to be, since we are going to get like CG, so C is right here. And then DG, D is right here. So I should have like maybe somewhere outside. It doesn't really matter probably, but let's try something to visualize. So these two are given. Again, it doesn't have to be really right there. So it could be somewhere to the left, but since this is like bigger than this, so maybe it is towards to the right side of the midpoint. So that is something we can at least say that. So that is like 40, and then this is going to be 30. Okay. And what else do we know? And then we want to find the BGE. So the B, G, and then E. So we are looking for the area of that triangle. So like first, maybe we can find all the variables. That might be our first good stuff. And then first thing, we have pairwise the each distances, but we also know the sum of these. So if I add these equations, so I will get actually something useful. So I have 1A, but 2B, 2C, and 2Ds. So if I want to say the sum of them is going to be like A plus B plus C plus D plus E, plus I have these three are actually repeated. So it's C plus, I'll say B plus D. When you add these four numbers, so that's 40, 70, 100. So you got 8, 9, 12, so 112. And I do know the sum of A, B, C, D, E is 73. So which means C plus D plus B is going to be 112 minus 73. So this is like 27 lesser than 100 plus 12 is going to be 39. So that should be BCD. Okay, so like we can find the pairwise now. So since we know the BC is 22, so to get 39 after adding D, so 22 subtracted from 39, so you will get D, 39 minus 22, which is 17. And then C plus D is like 31. So C and D is 39, so that means B is just 8. And then what else do we need? So let me write those. So B is 8. And then D is 17. And then we need C as well. So C plus D was 31. If this is 17, so that means this is actually 14. So like we want to find the area. So to get the area, we need like the height and the base in general. So we don't know the height. So, but the thing is, if you drop the height from this G to be here, that height will be height for this triangle as well. So which means if I find the height of this triangle, then that will be actually used to get the area of the BGE. So to do so, since we have all three sides, we can try to drop this altitude and then find like two Pythagorean. So on this right and the left, and then use that to solve the H, which is probably will be the good way to do so. But let me use the Helmholtz formula. So to use this Helmholtz formula, we use the half of this perimeter, right? So that should be 40, 30 plus 14 over 2, which is like 70, 84, which is half is 30, 42. So the area of the GCD, actually I'm going to use notation. So the GCD, that's just the area, is equal to 42 is our S, and then we subtract each side. So 42 minus 40 will be just 2. 42 minus 30 will be 12, and then minus 14 will be 28. And then we take the square root. So like we would like to kind of find this number without really multiplying. So one thing I can see, I can pull this 6 and 7 separately because people love 6 and 7, right? So this is 6 times 7. So then if I pull that 6 and multiply by 2, that's 12. That means another 12 will be 12 squares. So I can pull that 12 squared as 12. And then 7 and 7 out of this 28 will be 7 squared. So that should be 7. And you got 4 left over. So if I pull the square root of that, so you got just 2. So then the answer looks like 12 times 14 for the area of the GCD. So the rest is you can use the area formula for, you can find the height of this triangle, based on this one. And how do you find that? You drop the altitude. So let's say the h times 14 over 2 is going to be 12 times 14. So you cancel this, you got 7, cancel that 7, so you got 24. So the h is 24. As soon as you got the h, so then you got the answer as 24 times the entire bottom was 22 plus that will be 39. So that should be divided by 2. You got 12 times 39. So if I multiply by 10, you got 390, and then you got 2 times 39, which is 78. So I should be getting 468. Okay, so this is one way of doing this part, but the second thing we could have done instead of using this part, like I said, like we can use the Pythagorean to find the h. It's okay. But after we got the area right here, like you can use the bottom ratios to get the area of the other two pieces. Like this is 14, and then the area looks like 14 times 12. So I'm gonna say this region should be this guy will be 17 times 12, and then this region will be 8 times 12. So when you add 8, 12, 17, 12, and 14, 12, then that's also gonna give us the same region. So we just use the area relation with the triangle when they have this common vertex, which is really common as well. But anyway, so that was the first question. Okay, so here's the second one. The sum of all possible integer n such that n plus 2 divides the product evenly. Okay, so let's go ahead and like expand this one. So you will get 3 times n squared will be n cubed, and then n times 9 is 9n, and then you got 3 times n squared, and then you got 27. If you expand those, you got 3n cubed plus, and then you got 3 times 3 is like 9n squared, and then 3, 9 is 27, and then plus 81. So this is the expression that we are told that is divisible by this, right? So maybe we can use the long division, or we can use the synthetic division. So I'm going to use the synthetic division. So the n plus 2, if I make this equal to 0, so the n is -2, right? So we are going to use this number in our box. And then we start with 3, and then the second degree is 9. I mean, second degree has a coefficient of 9. And then now you got 27, and then you got 81. So we drag this, which is 3. And then this time, this will be -6. When you combine those, you got 3. And then 3 times this will be -6 again. So when you combine those, you got 21. And then this time, this will be -42. Okay, let me double check. So you got 3, that's -6. And then that should be 3, that's -6, 21. Okay, and then we got that, right? So it looks like, okay, so that should be 81 minus 42. So that is 39. So meaning that this actually is not divisible by even. I said even like first, but that's not the case. So when you divide the expression by n plus 2, we got this quotient. So we can just say this way, right? So the 3 times n plus 3 times n squared plus 9. When you divide this by n plus 2, maybe I should use the long division, but it's the same thing. And then we got this as my quotient. So you got 3n squared plus 3n plus 21 plus the remainder is 39 over n plus 2. Okay, so we are told what is the sum of all possible values of integer n? This divides this, right? Which is actually the case. So in order for this to be divisible, so that means 39 has to be divisible by n plus 2. So the n plus 2 has to be one of the divisors of 39. So it could be 1, 3, 13, and 39. We are looking for a positive n, so we have to be careful. And subtract 2 from both sides. So you got -1 and +1, and then you got 11 and 37. But this is not going to be counted because that's negative. So when you add the other ones, you got 1, 11, and 37. So you got like 38, 49, right? So that should be 49. So since this is AIME, so we're going to say 0, 4, 9. Okay, so that was like, I guess, number 2, which was also not too bad. So let's see the number 3. So this is actually a bit interesting. The 4-unit squares form 2 by 2 grid, right? And each of the 12-unit lines, segments forming the sides of the square is colored either red or blue in a way that each unit square has 2 red sides and 2 blue sides. And one example is given. Find the number of coloring. Like this is actually a bit challenging, to be honest, even though even like this common question, because if you really mess with your counting organization somehow, you can actually easily miss this problem. So off by 1 is not really forgive for the AIME test, right? So I'm gonna kind of make a case. Like usually whenever you have these kind of like grade, let's explore a bit first. Like I'm gonna make this right here first. So one thing I'm gonna try is ask myself, what is the most restrictive segments I really need to think of, because that's usually the one that we want to start with. So let's say if I want to color this one, that does not affect really other like a lot. So it does affect maybe 2 sides. But if I want to color like this one, it does affect 2 other like 2 units like square right here, but this also affects right here. So which means maybe we should actually start checking with the middle one. So like this one and this one and this one and this one. So I'm going to kind of go with some cases. But before we kind of do some cases, let's try to explore a bit more as well. So let's say if I want to have, I don't know, like say this is blue and then this is blue, like two horizontal ones. And I don't know, like I'll say this is, let's say, the red. So how many ways can we finish off? So like when these two are actually different, I can just choose this side as the blue and then this side is red, or this is blue or this is red, which means when two sides are kind of fixed, then we have two different ways of finishing each unit circle, like square. The same idea right here. So if these two are red and blue, so then you can have red here, or blue here, right here. So that means two ways to do so. But let's say if there is like blue right here, like blue and blue, then these other two left over has to be red and red. So there is no other option. So meaning that we can maybe find a way of or like organizing counting. So what I'm trying to say, like if you want to kind of say the number of ways to find the middle fourth in a way that we can kind of finish the middle fourth, because the number of ways to finish the middle fourth is actually will determine the other remaining two for each square. So that might be the good idea. Okay, so let's kind of start with that kind of case then. So I'm going to say my first case is going to be the horizontal segments. Let's write this case. I'll say 1. So I'll make a, okay, so let's say this is my, maybe I should use actually, because red is kind of the given color, so let's not use them. Okay, so imagine this is the one that we are given. So for now, I'm not gonna really consider the first color choices, because at the end, so if I choose the, let's say the red first, and then I can double that to make that blue as well. So my first case, I'm gonna choose as the horizontal two, like this guy, and this guy is red. Okay, so the horizontals are red. Two horizontals are red. Okay, and then, or two horizontals are the blue. So the horizontal ones are horizontal, same color. Okay, so which means whatever I get from this case, I'm going to multiply by 2 for the case for blues, right? That's horizontal. So now, if this is red, let's kind of think about it this way. Then, like, for us, we want to know the two other vertical ones as well, so we can finish the other two. Like, if this is, let's say, red, and this is also red, then when these two reds, these two are forced to be blue, these two are forced to be blue, and then same thing with this one. So which means, like, there's only one way to finish this one. And then I'll say, if I want to have these two are red, so there's only one way of doing this, right? So that is 1. Okay, so that wasn't too challenging. And then if I want to say, let's say this is red and this is blue, then this is red and red, so it means there is only one way to finish this, blue and blue, and then red and red, blue and blue. So that's one way to top square. But for the bottom one, since these are two opposites, and then there is two different ways to finish right here, two different ways to finish here. So that means 2 times 2, or 2 square. But I can choose this is R, this is blue, like, or this is blue, this is R. So that means 2 ways to determine those vertical ones. So I'm going to multiply this by 2 to consider those two different cases. And then the first one, for the vertical wise, like we chose, this is red and this is red, and then this is red, blue, or blue, red. And the last case is like blue and blue, right? So we can have that. In that case, if this is blue and red, that's 2 ways right here, 2 ways right here. But and then this is red, blue, red, blue. So which means every unit square has 2 different ways to finish up. So which means 2 to the 4th power. In this case, like we have 16, that's 4 times 2 is 8, plus 1 is 24, 25. But this is the case when the horizontals are the same color, but I choose this to be red, so I can make that blue as well. So which is why I'm going to multiply this by 2. So that will give us 50 cases, which is my first case. Okay, the case 2. Okay, so I'll say the let me write that. So the case 2 is the horizontal ones, the internal horizontal ones, basically, are different. Okay, so let's kind of explore this situation a bit. So in that case, like we should have something like this. We do have, this is a horizontal one, this is, let's say, the vertical one. And then what we want now is the horizontal ones are different. So I'll just choose this as like, say, red, and this is blue. And then we can just swap that order. So that's at the end, so just double it. So one thing we can do, if the top one is, let's say, blue, and this is blue, that's kind of easier to do so. So there is only one way to finish this one, because these two are blue, these two has to be red. But when these are different, there is 2 ways to do so. So that means there is 2 ways right here, and 2 ways right here, but 1 way right here. So that means 2 times 2, which is 2 square, when B right here and B right here. But this is the same story if this is like R and this is R, because when this is R, this is B, that's 2 ways right here, R 1 way here, R 1 way here, RB is 2 ways right here, so which is 2 ways to finish that as well. And then if the top and bottom, maybe I should have now these to be different, let's say this is like R, and then this is blue. So RB, we have two ways right here. RR, one way here. RB is two way, and then that's also one way. So that means two ways right here, two ways right here. One of the other ways. That's going to be two square ways times one, but that's just one. But we can swap these two. So which is why I'm going to multiply. This is B and this is R. In that case, there's two different ways as well. So this is the case when R and B in this order. So this one is R, which is red. This is the blue one. But we can actually double this number to make this is blue and this is R. And that will make our answer, I guess. So that's 4, that's 8. And that's 8 as well. That's 16 plus 2 is 32. So these are the actual two cases. Like the first case I said horizontal are the same color and horizontals are different. So each case we have our exclusive. So there's no actually overlapping. So we just want to add those together to get our answer, which is 80, 82. So I will say 0, 82. Okay, so that was number 3. So I hope that was clear. So I'll see you in the next video.